Hello, in this video I'll be going through how to draw Lewis structures for molecules and polyatomic ions in NCEA Level 3 and Scholarship Chemistry. There will be 3 questions that I'll be going through. One is the 2024 Thermochem past paper at Level 3, and the other 2 are at scholarship level. So let's look at the Level 3 paper first. We are asked to draw two Lewis structures, one for PF5, which is a molecule, and SeCl4 2-, which is a polyatomic ion. Let's look at PF5 first. We have to first look at if either P or F is our central atom, and in this case it will be P because P is in group 15 and F is in group 17, so P can make more bonds than F. So now we can easily draw our 5 fluorine atoms around the central phosphorus atom with its lone pairs, of course. After you've drawn the lone pairs, now we have to determine whether we need to draw lone pairs around the central phosphorus atom. We do this by first looking at the number of valence electrons PF5 should have. So let's take a look. Since P is in group 15, you'll have 5 valence electrons. And F is in group 17, so there should be 7 times 5. So there should be a plus here. Valence electrons. So 5 coming from the P and 5 times 7 coming from the 5 fluorine atoms. And this gives us 40 valence electrons. And now let's compare it with the number of valence electrons our drawn structure has. So the central atom has no valence electron anymore. Well, we assume that because all of its electrons are contributed towards the covalent bonds with F. So therefore we think each F has 8 valence electrons, coming from 6 coming from the 3 lone pairs that it has, and 2 coming from the covalent bond with P. So we have 5 fluorine atoms, each consisting of 8 valence electrons. This gives us 40 valence electrons. Since the numbers are the same, we know that we don't need to draw any other valence electrons, lone pairs, for the central phosphorus atom. So this is good, the structure is right. And now let's look at our polyatomic ion, SeCl4. Se is in group 16, so it has 6 valence electrons, and Cl is in group 17, so it has 7 valence electrons. Se is the central atom, but before we draw anything else, we'll put the big square brackets around the structure and put a 2- charge since it's an ion. Now let's quickly draw the 4 chlorine atoms around the Se, along with the lone pairs. After we've drawn the lone pairs, we'll determine again how many valence electrons that there should be on the central Se atom. Same as before, we look at the number of valence electrons that this structure SeCl4 2- should have. So Se is in group 16, so it has 6 valence electrons, and there are 4 chlorines, and each has 7 valence electrons. But this is not it, because we have to add on 2 more due to the 2- charge. So therefore we have 6 plus 28 plus 2, which is 36 valence electrons. And now let's look at our structure. Same principle as before. Chlorine. Each chlorine has 8 valence electrons, and there are 4 chlorines, so we do 4 times 8, which is 32 This is 4 less than what we expect. So we need to add 4 more electrons onto Se in order to give it a 2- charge. So this means there are 2 lone pairs on central Se atom. And now if we calculate it again, we have 4 times 8 from the 4 chlorines, and then we add on the 4. This gives us 36, which means the numbers match and this structure is correct.